I have an unheated, uninsulated, unair-conditioned garage, and occasionally I have to do work in it in the winter. And I have an old torpedo heater of the type used for construction sites that burns kerosene. And probably because of all the carbon monoxide it puts out, it gives me a headache if I work in the garage for very long with that on, even with, some ventilation. So I had another project coming up. I needed to have a heater, and I decided to get a propane fired unit, which is a lot better in regards to carbon monoxide generation, just generally cleaner burning and better for that kind of situation. I selected this DeWalt model DXH45FAVHC because that was the only model they carried in my local hardware store, and the price was right. I think these usually run for around $120 or so, and they had it on some sort of a sale, year-end sale, for about $89. So I'm just going to do a little bit of a review here, show the item, and say what I think about it. Included in the box, besides the heater itself, is a 10-foot long gas line or gas hose with an LP gas regulator attached at one end. The fitting on the other end of the regulator is the kind that's usually associated with smaller LP tanks, such as the kind that are usually used for barbecues. So it works well with that kind. And the other end, I'm not sure what type of fitting it is, but it screws onto the back of the heater. So for all I know, it may be proprietary, but certainly you don't have to worry about that end. Here's the heater itself. Looking at its left side, it has the base and then the actual forced air tube and combustion chamber is angled up somewhat up to the left in this view. Here's the basic specification. It's a maximum 45,000 BTU unit, although it is adjustable. Its rating is from 37,000 up to 45,000 BTU per hour, which is 10.8 to 13.2 kilowatts. Being a forced air heater, there is a fan. It's a fairly large fan, and you can see its blades through the grill on the rear end of the blower or the heater. It actually blows air through the combustion chamber as well as around the outside of the combustion chamber, which provides a sort of a cooling jacket so that the outside of the heater casing does not get hot to the touch or likely to start a fire if it comes in contact with something. Because of this main characteristic, I would say this falls into the classification of pretty much all the other torpedo heaters that are out there, regardless of what fuel they use for firing them. Speaking of firing, here's a view of the other end, the discharge end of the heater, and you can see the outer black-colored sheet metal tube, and then the inner, I don't know what metal it is. It's probably plated steel or something that makes the inner combustion chamber wall. And as I said before, a jacket of cooling air is blown by the fan between the inner and the outer walls here, so that while the inner walls get quite hot, the outer walls remain cool to the touch. But you can also see at the rear of the combustion chamber here all the holes through which both air and gas are sent so that they can ignite. And you can also see the igniter down there sort of on the left side of center. Actually, I think that central brass-colored protuberance there is actually the gas nozzle, and I think it just shoots jets of gas out in all directions from that center point, and then the holes in the sheet metal I think are just for air. Again, you can see the parts of the igniter here, and somewhere in here I believe is a thermostat of some kind that's used to detect ignition so it doesn't keep blowing gas out if there's no flame to burn the gas. I don't know the details of that, and the manual doesn't really go into it either. Here's a little schematic diagram from inside of the base once that's opened up. You've got a printed circuit board with a relay. It controls the motor. The AC power from the power cord goes into it. There's a gas control valve, which is apparently, I don't know if that's an input or an output, if the valve is controlled in some way from the circuit board, or if the circuit board can sense when the control valve is open. Not sure about that. It seems to be done with just one wire. I suppose it's using the sheet metal housing as the other conductor. Then there's a wire shown going to a thermostat and then also going onto a thermocouple. So I do believe that they have means in here just for safety of detecting when you don't have any combustion going on. That's pretty normal for gas jet heaters, that you don't want to just keep pumping gas out if there's no combustion to use that gas up. The side panel of the heater's base has basic specifications and also an abbreviated instruction manual for getting the combustion started, or lighting the heater essentially. And it's in at least English and French. There may be other instructions there too that I didn't pay much attention to. Here's the rear end of the base. It has two things on it. It has the gas hose fitting for gas coming into the heater, and it has a very short power cord. You definitely need to use this with an extension cord, but they don't give you anything more than this little pigtail of a power cord. So the heater will not work on gas alone. It is a forced air heater, so it definitely requires that fan to be operating, as well as what other stuff is on the circuit board that's controlling the fine points of its operation. The unit is designed for 120 volts, 60 hertz, and requires about 1.75 amps. It says in the manual that its minimum operating voltage is 100 volts. The heater only has one control, and it's a large knob which also pushes in against a spring. At the far right of the rotation is the off position, and then rotating it counterclockwise increases the gas flow and or some other aspect of the control that ultimately results in how much heat you get out of it and probably how much gas is burned per hour. The ignition position is roughly in the middle of the rotation, but that is also where the lowest on position is, so you start it with a low gas flow. Starting is pretty simple. First you plug it in, make sure the fan is running, and then open the valve on your gas tank, and they recommend waiting about 20 seconds after that, and then push in the knob, and while holding it pushed in, rotate it counterclockwise to the minimum on position, which is also marked low and ignite, and then releasing the knob pops a piezo sparker basically, or a piezo igniter, and that gets it started. If you don't hear it start, you have to turn the knob all the way back to off to reset it, push it in, turn it back to the ignition position again, and do that until it starts. If the gas supply is shut off or runs out of gas while the heater is operating, it just keeps running the fan and the flame goes out and it's safe. If you're running the heater and you want to shut it off, you simply turn the knob back clockwise until it gets to the off position, and that'll shut off the gas and have the same result. but you always want to follow that up with shutting off the valve on the gas tank itself. I took the bottom plate off of the base of the heater just to see what was inside, and you can see there's the main gas valve. That's the big metal assembly in the middle. There's some wiring, and there's the small printed circuit board. And here's a somewhat zoomed in view of the same thing. Here are a couple of views of the printed circuit board. Besides a couple of connectors and the relay, it seems to be mostly a fuse, some diodes, a few resistors, and not much else. I don't think there's any real solid state intelligence on this circuit board. And this view shows a few of the wires of various kinds that are going through a hole into what I believe is the rear of the combustion chamber. So I believe that has to do with the igniter and the thermocouple sensor and that kind of thing. Because the piezo element that generates the high voltage for the igniter spark appears to be part of the knob assembly, which is the gas control as well, it didn't surprise me that there's this high voltage wire coming out of the back side of that gas valve assembly and then running into the combustion chamber area. I made a small hack on mine by buying a set of rubber feet from the hardware store and screwing those onto the base plate of the heater, as you can see here. That just makes it sit better on the floor. Connecting the gas hose is as easy as just threading it on and tightening it with a wrench. The gas hose is actually pretty stiff on this. It wants to stay coiled, and the heater doesn't weigh very much. That's one reason I put the rubber feet on it, because there was enough kind of springiness to the coiled hose that it wanted to slowly pull the heater backwards across the concrete floor of my garage. So putting the feet on it kept that from happening. The gas tank valve operates in the direction that one would normally expect, turning it counterclockwise to open the valve. But the threading on of the fitting for the gas hose is contrary to what you'd normally do by instinct. Instead of the old lefty-loosey, righty-tighty, it's the other way around. You have to turn it counterclockwise to tighten it. So I've actually marked that on my tank. I don't use a rented tank. I own my own 20-gallon tank. So here's putting the regulator end of the included gas hose and threading it into the valve fitting on top of the gas tank. And here's with it threaded in all the way. Note that the included hose fitting actually threads onto a set of internal threads on the tank's valve housing, but there's an external set of threads that looks like it may facilitate a different fitting that may go on a little easier, or maybe just tightened by hand. I'm not sure, but you can see the threads, and that set of threads looks like it would be tightened by turning clockwise. So I'm not familiar with that. The one that comes with the heater tightens by turning it counterclockwise. Here is the heater in use in my garage with my 20-pound tank, and while I'm working on a project on my snowblower. I ended up using the heater pretty much continuously during daylight hours for 2 days because I was going from my basement shop out to the garage, doing a little bit, coming back and forth, but I wanted to keep it warm in there. So I don't know what it ended up being. It could have been this, probably 12 hours maximum a day for almost 2 days. And with the heater knob set to the low position, which is where I had it, that's about right according to the specifications. If you start with a fully loaded or fully filled 20-pound tank like the one I have, you could maybe get, 16 to 20 hours of operation out of that. I did have to take it back and get it filled again. I think it was about $14 to get that 20-pound tank refilled, and then I ran it again for maybe another 8 hours to finish up my project. But that's actually pretty good. It's smaller, it's lighter, it's a lot easier to deal with than my other torpedo heater. So I call this one a win.